Section 9.9, our objective today is to solve systems of linear equations in 3 variables. So a linear equation in 3 variables in standard form would look like this. And the solution would be in what we call an ordered triple, which is the triple x, y, z. Notice that that is in alphabetical order. Example 1 here is an example of a system of equations in 3 variables. And we say that this is a triangular system because notice that it looks kind of like a triangle. And when the system is in this form, we can solve the system very easily because we work backwards since we know that z equals 4. Then we can take that 4 and put it into this equation and find the y. So we get y minus 4 equals negative 5. So write that better, negative 5. And so then solve for y, so we get y equals negative 1. Now we take the y and the z and come up to the first equation and solve for x. We have 3x plus 2 times negative 1 plus 4 equals 8. And so we get 3x, that's a negative 2 and a 4, plus 2 equals 8. Subtract 2 from both sides, 3x equals 6. Divide both sides by 3, we get x equals 2. So the solution to this system is the ordered triple 2, negative 1, and negative 5. So that is the solution. So, I'm sorry, and positive 4. I don't know where I got the negative. Oh, I see. Yeah, it's positive 4. So it's 2, negative 1, and positive 4, because z was 4 here. Okay, so that is the solution to our system. So when we are given a system that is not in that form, and not in that triangular form, our goal then is to get it into that form so we can solve it. So example 2. So we have x plus 3y plus z equals 8. 3x plus 2y minus z equals 14. And 2x minus y plus 3z equals 1. Okay, and I'm going to number these equations. This is equation 1, equation 2, and equation 3. So what we're going to do is step number 1. Use equation 1 to eliminate x from equation 2 and 3. Okay, so I'm going to take x plus 3y plus z equals 8 and 3x plus 2y minus z equals 14. And so this is equation 1 and equation 2. And what I want to do is I want to eliminate this x from equation 2. So I need to multiply the top equation by negative 3. So I get negative 3 times x plus 3y plus z equals 8, which gives me negative 3x minus 9y minus 3z equals negative 24. And I write equation 2 right under that. And I add those together. So when I add those together, notice that the x's add up to 0. So these add up to 0. And then negative 9y and positive 2y is negative 7y. And negative 3z and negative z is negative 4z. And negative 24 and positive 14 equals negative 10. Okay, so this now is equation 4. Okay? Now I'm going to do the same process with equation 1 and equation 3. So equation 1 was x plus 3y plus z equals 8. But now I'm going to use equation 3. Okay? So I need to multiply equation 1 by a negative 2. Okay, notice I'm going to multiply the whole equation by that. So I'm going to get negative 2x minus 6y minus 2z equals negative 16. And then I'm going to write equation 3 right under that. That's a z. Okay, then I'm going to add those together. So notice that these two add up to 0. This is negative 7y plus 1z equals negative 15. So now this is equation 5. Okay? Now step 2, use equation number 4 to eliminate y from equation 5. Okay? So equation 4 is negative 7 minus 4z equals negative 10. Equation 5 is negative 7y, whoops, I forgot my y there, plus z equals negative 15. So if I take equation 4, and let's highlight equation 4 because we don't want to lose that one. Okay? And the same thing with equation 1. Okay? We want to highlight that because we want to come back to that. Okay? So I need to take equation 4 and multiply it by negative 1. Keep forgetting that y. Okay, and so that's going to be 7y plus 4z equals 10. And then I write equation 5 right underneath it. Okay, and so now I add those together, and I get, this adds up to 0, so I get 5z equals negative 5. So z equals negative 1. This is equation number 6. Okay, so now we take equation 1, equation 4, and equation 6. So equation 6 was z equals negative 1. Equation 4 was negative 7y minus 4z equals negative 10. And equation 1 was, was x plus 3y plus z equals 8. And now we have an equation in triangular form, and now we can find our ordered triple. So use this here. So we get negative 7y minus 4 times negative 1 equals negative 10. Okay, so, and if we subtract 4 from both sides, we get negative 7y equals negative 14. Divide both sides by negative 7. We get y equals 2. So now we take our z and our y and put it into equation 1. So we get x plus 3 times 2 plus negative 1 equals 8. And so I get x plus 5 equals 8. Subtract 5 from both sides, so I get x equals 3. So our ordered triple is 3, 2, and negative 1. That is the solution to the system, which means that 3, 2, an x value of 3, a y value of 2, and a z value of negative 1 makes all three of the original equations true. Okay? So if I put those values in to this equation, that side's going to equal 14. If I put those values into this equation, that side's going to equal 1. And of course, if I put them into this equation, that side's going to equal 8. Okay, so we found the solution. All right, let's do one more. Okay, just so that you, so this is example 3. So I have 2x plus y, minus 2z equals 4, and x minus y plus 2z equals 8, and 3x plus 2y minus z equals 10. All right, now on this one, what we probably want to do is reorder it, because remember we want to use one equation to eliminate the variables from two other equations. So what I'm going to do is I'm going to say this is my equation 1, this is my equation 2, this is my equation 3. Okay, and that does not change anything. Okay, so now this is equation 1, this is 2, and this is 3. So I'm going to use equation 1 to eliminate the x's from equation 2. So x minus y plus 2z equals 8, and 2x plus y minus 2z equals 4. So I'm going to multiply this equation by a negative 2. So it's going to give me negative 2x plus 2y minus 4z equals negative 16. Add those together. These two add up to 0. So I get 3, whoops, should be a positive 3y. 3y minus 6z equals negative 12. So this is now my equation 4. Okay? So remember, we want to hang on to equation 1, okay, and equation 4, right? But now we're going to use equation 1 to eliminate the x's from equation 3, okay? So we're going to take x minus y plus 2z equals 8, and 3x plus 2y minus z equals 10. And I'm going to multiply this one by negative 3. So it's going to give me a negative 3x plus 3y minus 6z equals negative 24. Copy equation 3 underneath and add them together. Whoops. So these two add up to 0, so I get 5y minus 7z equals negative 14. So this now is equation 5. So now take equation 4, which is 3y minus 6z equals negative 12, and equation 5, which is 5y minus 7z equals negative 14. Now in this case, to eliminate the y from equation 5, I'm going to have to multiply this one by, say, negative 5, and this one by a positive 3. So that's going to give me negative 15y plus 30z equals 60. And then 15y minus 21z equals negative 42. Okay, add those together. These have to add up to 0. And so we get 30z minus 21z is going to be 9z equals, and this is going to be a positive 18. Divide by 9. So z equals 2. So now equation 1, remember, was x minus y plus 2z equals 8. Equation 4 was 3y minus 6z equals negative 12. And remember now that this is my equation 6, so z equals 2. Now we have our equation in triangular form, so now we just work backwards. Put 2 into this equation, so we get 3y minus 6 times 2 equals negative 12. Oops, forgot my negative there, negative 12. So I get 3y minus 12 equals negative 12. Add 12 to both sides. So I get y equals 0. So now I take the 2 and the 0 and put them in here in equation 1. So I get x minus 0 plus 2 times 2 equals 8. So x plus 4 equals 8. So x equals 4. So our ordered triple is 4, 0, 2.